Problem number 8. Change this Cartesian integral into an equivalent polar integral and then evaluate. Okay, what are our bounds here? X runs from 0 to 4. Y runs from 0 to square root of 4 minus x minus 2 quantity squared. Okay, so the first thing that we should kind of be flagging here is what's going on with the curve y is equal to the square root of 4 minus x minus 2 quantity squared. Well, let's substitute in. Y is r sine theta. X is r cosine theta. Okay, so this is going to be, squaring both sides, gives us r squared sine squared theta is equal to 4 minus r cosine theta minus 2 squared. Expanding this out, we get 4 minus r squared cosine squared theta plus 4r cosine theta, and then minus 4. So those would cancel out. And moving this to the other side, we'd have r squared sine squared theta plus r squared cosine squared theta. That, of course, is equal to r squared, and that's going to equal 4r cosine theta. So cancel out a factor of r, we'd have r is equal to 4 cosine theta. So one of the bounds in terms of r in terms of theta is going to be r is equal to 4 cosine theta. Okay, that is partway done. What does this look like graphically? If you know what r is equal to 4 cosine theta looks off the top of your head, that's great. I'm going to kind of do it from scratch, going back here. If we say, hey, squaring both sides without converting to r's and thetas, y squared is equal to 4 minus x minus 2 quantity squared. Moving the x minus 2 quantity squared to the left gives us x minus 2 squared plus y squared is equal to 4. We should recognize what this is. This is a circle. So it's a circle of radius 2, and it's centered at the point x is 2, y is 0. So now, what does this look like? So let's see here. Here's a circle of radius 2, centered at the point 2, 0. So x can be anything from 0 to 4. Y can be anything from 0 till we hit the circle. So this is the region that we're integrating over. The top half of this circle centered at the point 2, 0. So we also know that the equation for this part of the circle here is r is equal to 4 cosine theta. Okay, so we need bounds on theta and r for this region right here. Theta can be anything from 0 to pi over 2. R can be anything from 0 to 4 cosine theta. And so this allows us to say that the integral is equal to theta runs from 0 to pi over 2. R runs from 0 to 4 cosine theta. What about the integrand here? X plus y becomes r cosine theta plus r sine theta. X squared plus y squared is r squared times our factor of r we always have, r dr d theta. Okay, there's a factor r upstairs times this r over here is r squared over r squared. So all of those cancel out. So here, all we are integrating here is just cosine theta plus sine theta dr d theta. Okay, so integrate this with respect to r. There's a constant with respect to r, so we just get r times cosine theta plus sine theta d theta. Oops, and plug in r from 0 to 4 cosine theta. And so we'd end up with theta is running from 0 to pi over 2. R is 4 cosine theta times cosine theta plus sine theta. So 4 cosine squared theta plus 4 cosine theta sine theta d theta. When we plug in r as 0, that would just be 0. And so if we evaluate this, I think that we should end up with, if we evaluate this, the integral of 4 cosine squared theta on this interval should be pi plus, I think this should just be pi plus pi is 2 pi.